right, so we are moving on to our very last section of triangle trigonometry. And what we're going to deal with now is non-right triangle trigonometry. So what we've been talking about was all the right triangles. And the thing that we use on right triangles is Pythagorean theorem. And we also use your SOHCAHTOA. So any of that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, all of that stuff only goes with right triangles. And a lot of times, most of the time in the real world, what you're going to get is a non-right triangle. And we have formulas that work specifically for non-right triangles. These formulas are in your formula packet. So these ones you do not have to memorize, whereas like SOHCAHTOA, you do have to memorize. So these guys are in your formula packet and they are only used for non-right, which you can see. It also says it right here, but for extra importance, non-right. So let's say that I have a right triangle that is specifically a non-right triangle. How we label triangles just in general is that the uppercase letters are always the angle. So if I were to label this A, B, C, your uppercase letters are always the angles. Whereas the lowercase letters are the sides that are opposite of that angle. So if you want to imagine the spotlight again that opens up onto the opposite side length, A spotlights onto A, B spotlights onto B, and C spotlights onto C. So this is how we just label triangles in general, which is important because the formulas rely on this labeling process, on the relationship of an angle and its opposite side. The law of sines says that sine of any angle divided by its opposite side is equal to sine of any other angle divided by its opposite side. Now, it does not matter which angle you choose and which opposite side. This relationship will hold true no matter what. So you could say also sine of A over A equals sine of C over C, or sine of B over B equals sine of C over C. It does not matter. As long as you choose an angle and its opposite side, this relationship will hold true no matter what. Okay, let's practice it. We want to find the value of the missing side length x in this triangle correct to 2 decimal places. So we want to look at angles and their opposite sides. So 25 goes to x and 65 goes to 14. So I'm going to do sine of 25 divided by its opposite side equals sine of 65 divided by its opposite side. So remember, if you don't know how to solve this, that is okay. You can just use your numerical solve. So if you are somebody who keeps forgetting how to use numerical solve on your TI Nspire, it is menu 3, 1, and there you go. And you can type this in. You can do, make sure to use your trig button on your calculator, sine of 25 divided by x equals sine of 65 divided by 14. Don't forget to put in your comma, which is down here by O, and then do x again. Okay, so that is the answer that we get for x. 6 point, and we want to do 2 decimal places, so 6.53. All right, next problem. I'm going to go ahead and walk you through this. I would absolutely recommend using your numerical solve for this guy. So angle and its opposite, angle and its opposite, sine of 60 divided by 9 equals sine of theta divided by 10. Go ahead and use your numerical solve for it if you can, and tell me what you got. You should have gotten with your numerical solve that theta is equal to 74.2 degrees. Now, there is a catch, and I want you to write to the side of here of watch out, danger, Will Robinson. Watch for an error. The thing with solving for angles using the law of sines is that there's actually technically, with this information that you've been given, two different triangles that you can create. So you've got this angle right here, but also if I replicated that angle of 9 down here, making an isosceles triangle, which would be something like here, this could also be 9, which means that this information holds true for this triangle, but also for this triangle. So there's two different triangles that you can make using this information, which means that your answer is not unique. You could get a second answer because this angle would be different. Let's call this angle alpha. And the relationship between theta and alpha is that they add up to 180 degrees. So if I had made a triangle that looks like this, and made alpha instead, you would still set up the exact same relationship. Sine of 60 divided by 9 equals sine of, this case, alpha divided by 10, but you would still get 74.2. Well, that would be incorrect, and the right answer would be 180 minus 74.2. All of this to say is I would not use law of sines to solve for an angle ever. If possible, use law of cosines, which we're going to learn about, or use the law of sines. Use law of cosines to solve for other side lengths, and then use those other side lengths to then use law of cosines to solve for an angle. So I would only ever use the law of cosines to solve for an angle, only. All right, that being said, let's learn about the law of cosines. Again, we can draw any triangle that we want. We're going to label it with uppercase letters. And then the sides with lowercase letters. And here is the relationship that's going on. There is a formula. It is lowercase c squared equals a squared plus b squared minus 2ab cosine of c. The relationship here is that all of these guys are side lengths. And the thing that matters the most is this guy and this guy. If you have a highlighter, maybe highlight those in the same color, because the relationship is an angle and its opposite side. That is the relationship that has to happen here, is that the side that goes over here has to be the side length that is opposite of this angle. So every time you're using the law of cosines, that's the first thing you need to look for, is what angle am I looking at and what is its opposite side? And that's going to help you set up the problem correctly. Now, a lot of students get really stuck because they focus on the C thing, and sometimes you might get a triangle that's labeled. You don't have any that are labeled here, which is good, but sometimes you might get a triangle that's labeled like A, B, C, and you think that angle C is the only angle that can go into law of cosines, and that's not really the case. These are just the angles that this is just the angle that was happened to be chosen, but you could do lowercase a squared equals c squared plus b squared minus 2cb cosine of uppercase A. That is also the law of cosines. You could do it with B. And the relationship here is it has to be the side length and its opposite angle. That is key. All right. So going ahead and using our calculator, find the value of the missing side length correct to 2 decimal places. We have an angle and its opposite side. So that means that uppercase C is 30 and lowercase c is x. So when we build our formula, it's going to be x squared equals. And then from there, it doesn't matter which one's 3 or which one's 4 and which one's 5. So I'm going to do 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of 30. Okay, use numerical solve if you want to use numerical solve. If you do not have numerical solve, if you have a TI-84, you can just plug this in exactly as you see it. 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of 30. And you get that x squared is equal to 6.36. I'm going to take the square root of that exact guy. So I'm going to scroll up and press enter to bring it down. And I get that x is equal to 2.52. Hopefully that is what you got if you use numerical solve. All right, I would like for you to now do B on your own. Okay, so again, we're trying to focus on an angle and its opposite side. So that means uppercase C here is going to be 150 and lowercase c is going to be x. So that means we've got x squared equals the square root of 17 squared plus 6 squared minus 2 times the square root of 17 times 6 times cosine of 150. Okay, so go ahead and plug this into your numerical solve, or you can just plug this step by step directly into your calculator. And what you should get is that x squared is equal to 95.85 about, and then take the square root of both sides, and you get that x is equal to 9.79. E basta. All right, solving for angles. This is the way I would recommend solving for angles every single time, just because it won't give you what we call the ambiguous case. So the ambiguous case was that where you could draw two triangles on either side from your previous page. So this one will not give you an ambiguous case. So that's why it is easier in that regard. It's harder in other regards because it's just harder to isolate if you don't have numerical solve. So this is, I think, harder if you don't have numerical solve because isolating for cosine is going to be really hard. Before we can do the inverse, you have to isolate the trig value. So focusing like we always focus on the angle and its opposite side. 10 squared equals 11 squared plus 7 squared minus 2 times 11 times 7 times cosine of theta. We need to isolate for cosine, which means we need to, if you have, think about it for a second, if you had a term plus another term plus a number, so let's do it this way. If you had a number plus a number, and it's minus a number times a variable, you would undo the addition subtraction first and then undo the multiplication. It is a very common mistake to try and combine all of this first. And you cannot do that because this is being multiplied to cosine, which means you need to divide it out. It's hard. So what you do is you do 10 squared minus 11 squared minus 7 squared. You subtracted 11 squared from both sides and 7 squared from both sides. Now, getting rid of those guys, you're left with negative 2 times 11 times 7 times cosine of theta. From that, you then need to divide both sides by negative 2 times 11 times 7. Divided by 2 times 11 times 7 equals, negative 2 times 11 times 7, and it equals cosine of theta. Now that you've isolated for cosine, now you can do your inverse guy and flip those out. So trig, scroll down and over to your inverse trig, and I'm going to do a parentheses for the numerator, 10 squared minus 11 squared minus 7 squared. Get out of the numerator, divide, parentheses for the denominator, negative 2 times 11 times 7. And now I hit enter, and you get that theta is equal to the nearest degree, so we'll round to 63 degrees. This process is tough. It's really hard. It's a lot of steps, and I bet it's very anxiety ridden for those of you who have a TI-84. TI Nspire is going to be very helpful with that if you have